classifications here: natural numbers, whole numbers, integers, rational, and irrational numbers. Okay, so what I'm going to do is just write a couple of examples here up on the board, and we're going to classify them. So we'll start with something simple. We'll start with the number 3. Okay, again, a very basic example, but now what we're going to do is we're going to figure out which category this belongs to, which classification does this number belong to. Okay, so remember our natural numbers, those were also known as the counting numbers, the numbers you use to count with, your 1s and 2s and 3s and 4s and 5s. So as we can assume, this would be a natural number. Okay, now let's just keep going down the list. A whole number. Now the only difference between natural and whole numbers is you add the number 0 in with the whole numbers. So 0, 1, 2, 3, 4, 5 are all the whole numbers. So 3 is included in that, so this is also a whole number. Okay, going down the list, integer. Integers include the whole numbers and the negative whole numbers, so -1, -2, -3. Okay, 3 is included in that, so it's also an integer. A rational number. Okay, now this one's a little tough. Rational numbers are the fractions, any number that you can make into a fraction. So, for example, 3, I can also write 3 as 9 over 3. I can write it as 12 over 4. I can write it as -27 over -9. There's lots of all these fractions, they reduce to 3. So there's lots of different ways to write 3 as a fraction. Okay, but just with the knowledge that I can write it as a fraction, that also makes this a rational number. Okay, now last but not least, the irrational. Okay, irrational numbers are the numbers that that repeat forever and ever and ever and don't have a pattern to them, similar to pi. Well, 3 is actually a terminating number. It just stops. There's only one number to it. There's no repeating digits, nothing like that, so it is not an irrational number. Okay, so there's one example. Now, what's confusing about this with some students is they think, oh, there's only one classification for a number. No, there can actually be multiple. 3 is natural, it is whole, it is an integer, and it is a rational number. Okay, so lots of different classifications for one number. Okay, so let's do something else. Let's do, for example, I'll think of a good example here. See, on my last video, I did the example of 1/3. Okay, so we'll use that. 1/3, I was going to go through this again. Now, is 1/3 a natural number? No, natural numbers are counting numbers, so no, 1/3 is not a counting number. We don't count by thirds, we count by 1s and 2s and 3s. It's not a natural number. Is it a whole number? No, it's not a whole number either. Is it an integer? Again, integers are whole numbers and the negatives, so it's not an integer. Is a rational number. Now remember, rationals are fractions. So we've actually found the first one that works for 1/3. It is a rational number. Okay, now rational, is it irrational? Well, we got to think, does it terminate? Is there a lot of repeating digits with this? 1/3, we all know that 1/3 is also equal to 0.333333, also known as 0.3 repeating. Okay? There is a pattern to 1/3. If you take your calculator, take 1 divided by 3, there is a pattern to it. It's just repeating 3s. 3, 3, 3, 3, 3. It's not much of a pattern, but it is a pattern. Since there is a pattern to this repetition, that means that this is going to be a rational number. It's not going to be an irrational number. If there wasn't any sort of pattern to it, again, I like to reflect and look at pi as one of those irrational numbers. Okay, so actually 1/3 is just a rational number. That's the only classification that we have. So a lot of your fractions that don't reduce are going to be rational numbers. Okay. Let's think of another one. Okay, so I mentioned a little bit before your negative numbers. This one I'll do very quickly. -5. Okay. With this number, again, we're going to go through our 5 different classifications. -5, is it natural? We don't count by -5, so nope, it's not a natural number. Is it a whole number? No, whole number is 0, 1, 2, 3, 4, 5, so on and so forth. It's not a whole number. Integer, yes, integers include the negative numbers. So we found our first classification for -5, integer. Okay, is it a rational number? Again, rational, can I make it into a fraction? Well, if I take negative 25 divided by 5, that will reduce back to negative 5. I can make negative 5 into a fraction, so that also makes it a rational number. Okay, and then irrational, again, is it repeating? Is it non-terminating? Is there a lot of digits afterwards? Is there no pattern to it? I don't see any of that for an irrational number. So negative 5 is not an irrational number. Okay. Let's just do another one. How about negative 0.01257839112 ... This number I put up here, and again we're going to go through the same process. Is it a natural number? We don't count by this decimal, so that doesn't work. Is it a whole number? No, whole numbers are 0, 1, 2, 3, 4, 5, so no, it's not a whole number. Is it an integer? Well, you might think, oh, it's a negative number, but no, that doesn't make it an integer. It's got to be a whole number. Your negative 1s, negative 2s, negative 3, negative 4, negative 5, or 0, 1, 2, 3, 4, 5, one of those. So it doesn't work there. Rational, can I make this into a fraction? Well, if I look at this, there's no repeating pattern to it. 0, 1, 2, 5, 7, it doesn't repeat at all. I see some of the same digits, but it doesn't necessarily repeat. There's no pattern to this. So actually, this would be an example of an irrational number. This is an irrational number. So again, this is very similar to pi, very similar to some other irrational numbers that we have. So this would be an example of an irrational number. I just wanted to throw one of those in there for the end. And again, these are just a couple of examples of how to classify real numbers. And again, our 5 classifications: natural, whole, integer, rational, and irrational.